This is the video for 4.1 to 4.3 study guide. Okay, so for the first 4 questions, they're just asking you to determine whether the ordered pair is a solution of the system. So all I have to do is plug in the ordered pair into both equations and make sure that both of the statements end up being true. So the first thing you want to do is label the point, x and y, and plug in. Let's plug into the first one. So I have 2x equals negative 5 minus y. So we're going to plug in negative 4 for x and 3 for y. So I have this is negative 8 is equal to negative 5 minus 3. Oops. Negative 5 minus 3 is negative 8. So this one works out. And then we're going to plug in, we've got 3x is equal to negative 6 minus 2y. So we're going to plug in negative 4 for x and 3 for y. So this is negative 12 is equal to negative 6 minus 6. So negative 12 is equal to negative 12. So that is also true. So number 1 is yes. All right, number 2, label x, y. So we have x plus y is equal to negative 2. No, Gabby, I will not be your best friend. I wish you would stop asking me that. Okay, so you've got... Alright, so we're going to plug in 4 for x and negative 6 for y. Make sure you use your parentheses so you don't get confused if you have negative, negative. So you have 4 minus 6 is equal to negative 2. 4 minus 6 is negative 2. So this one works. And then you have x minus y is equal to 10. We're going to plug in 4 for x minus, and then make sure you use your parentheses because here you do have minus a negative, equals 10. Add a line, change the sign. 4 plus 6 is 10. So 10 equals 10. And this is also a solution. So yes. So here, label x, y, same thing. So we have 3x plus y is equal to 6. We're going to plug in 1 for x and 3 for y. 3 times 1 is 3. 3 plus 3 equals 6. We know that's true. So then over here we have 2x plus 3y equals 11. We're going to plug in 1 for x and 3 for y. 2 times 1 is 2. 3 times 3 is 9. 2 plus 9 is 11. That's also true. So yes, this one is also a solution. So we have x and y. So we have 3x plus y is equal to negative 11. So we're going to plug in negative 3 for x and 2 for y. 3 times negative 3 is negative 9 plus 2 is equal to negative 11. Negative 9 plus 2 is actually negative 7. Negative 7 is not equal to negative 11. And the second that you get one of them not being true, you don't even need to try the next one. Because if one of them is not true, then it is not a solution. So you can immediately say, no, this is not a solution. You don't even need to check the next one. So now they have solved the system by graphing. Now, I said this in class, but I'll say it again. If for some reason you struggle with graphing, you don't necessarily need to solve them by graphing. You can solve it using elimination or substitution. And then, because I'm not going to check the test, I'm just going to check to see where your answers are. But I will solve this by graphing. So I'm going to subtract x from both sides, giving me negative y is equal to negative x minus 1. And then I'm going to divide each piece by negative 1, giving me y equals x plus 1. So my y-intercept is 0, 1. We go up 1 over 1, up 1 over 1, up 1 over 1. So this is my line right here. Okay. And then here, I'm going to subtract x from both sides, giving me 2y is equal to negative x minus 13. Then I'm going to divide everything by 2. Which gives me y equals negative 1/2 x minus 13 over 2. Okay, so on this one, your y-intercept is negative 13 over 2, which is negative a little over 6, 6.5. So that's right here.
Can I use your calculator? quick?
So you're going to go down 1 over 2. And then if you want to go up 1 and over 2, up 1 over 2, up 1 over 2.
Is she talking to you?
I'm talking to the video.
Oh, sorry.
That's okay. Okay, so even on a graph, it's really difficult to tell what my intersection is, right? Because of this weird y-intercept. So I'm going to check my work by solving this either with substitution or elimination. So I'm going to do x minus y equals -1, and x plus 2y equals -13. I'm going to use elimination. So I'm going to multiply the bottom equation by -1. So that gives me x minus y equals -1, and -x minus 2y equals 13. Which gives me, these cancel, and that gives me -3y is equal to 12. Divide both sides by -3, and I get y equals -4. I'm going to plug back in. X minus -4 is equal to -1. Add a line, change of sign. X plus 4 equals -1. Subtract 4 from both sides. You get x equals -5. So my point is -5, -4. Okay, and I strongly suggest you do that on the test if it's not an obvious intersection, which that was not. Here, I'm going to subtract 2x from both sides, giving me y equals -2x minus 6. Let's go ahead and graph that. So it's -6, and I'm going to go down 2 over 1. And then if I go up 2 over 1, down 2 over 1, up 2 over 1. Okay. Let's go ahead and connect those. Okay. And then I've got subtract x from both sides. And I have -3y is equal to -x minus 10. Divide everything by -3. And again, this is an ugly one. Y equals 1/3 x plus 10/3. But let's go ahead and try it again. So this is going to be like 3.3. So it's going to be about right here. And I'm going to go up 1 over 3. About here. And then down 1 over 3, about right here. Down 1 over 3, about right here. So if I cross them, looks like my intersection is going to be right here, which is -4, 2. Okay, and our solution on the study guide says y equals 2, so we know that y is 2, so we know that our y is at least right. So again, I would check this using elimination or substitution, but we got our y value right, so we're going to go, okay, solve the system by graphing. So we have subtract 2x from both sides. So I have y equals -2x plus 6. Subtract 2x from both sides. Y equals -2x plus 4. So we should be able to tell what the answer is right here. I've got two different y-intercepts, same slope. So what does that tell you? That you're going to have parallel lines. But let's go ahead and pretend we didn't notice that. So if I've got 6, and I'm going to go down 2 over 1, down 2 over 1. It's going to look like this. Okay. And then if I've got 4, down 2 over 1, down 2 over 1. Okay, it is two parallel lines, so your answer is no solution. Thank God we're done with graphing on those. Now, let's go ahead and solve these by elimination or substitution. Let's get into the real meat of this. So we're going to go ahead and put all of these over 1 and use our LCDs to solve. So you've got to look at your denominators. We're going to use our largest denominator and say, does 4 go into 4 evenly? Yes. Does 3 go into 4 evenly? Nope. So go on to the next one. 8. Does 4 go into 8 evenly? Yes. Does 3 go into 8 evenly? Nope. So let's try the next one. 12. Does 4 go into 12 evenly? Yes. Does 3 go into 12 evenly? Yes. Does 1 go into 12 evenly? Yes. So 12 must be our LCD. So we've got 12 divided by 4 is 3. 12 divided by 3 is 4. And 12 divided by 1 is just 12. So when we multiply 12 times x, 3 times x is 3x, minus 4 times y is negative 4y, equals 12 times 1 equals 12. And then now we're going to find our LCD for our bottom equation. So 4, 1, and 1 is going to be obviously 4. So 4 divided by 4 is 1. 4 divided by 1 is just 4, and 4 divided by 1 is just 4. So I have 1 times x is just x. Negative 4 times y is negative 4y, equals 4 times 3 is 12. So now, let's see what I can multiply by to get rid of either my x's or my y's. If you notice, my y's are the same, I just have the same sign. So why don't I multiply one of the equations by negative 1 to change my signs? So I'm going to leave the top equation alone, and I'm just going to multiply negative 1 by my bottom equation, which just changes all my signs. Okay, so this is my new system. 3x minus x is 2x. These cancel. Equal 12 minus 12 is 0. Divide both sides by 2. You get x is equal to 0. You're going to plug that back in. I'll plug it back into the top equation. 3 times 0 minus 4y is equal to 12. 0 minus 4y is equal to 12. Negative 4y is equal to 12. Divide both sides by negative 4. Y is equal to negative 3. So I have 0, comma, negative 3 is my solution for number 8. Number 9. Now this is one that's screaming substitution because I already have y solved for here. So I'm going to go ahead and take negative 3x and I'm going to plug it in for y there. So I have x plus negative 3x is equal to negative 2, which is really just x minus 3x is equal to negative 2. X minus 3x is actually negative 2x. So I'm going to divide both sides by negative 2, and you actually get x equals 1. And then I'm going to plug this x equals 1 back in here to find out what y is. So I know x is 1, so it's actually y equals negative 3 times 1. So y equals negative 3, and my ordered pair is 1, negative 3. Okay, got an LCD here I'm going to need to take care of, so I'm going to put everything over 1 to take care of my fractions. We've got 7, 14, and 1. So let's start with my largest denominator, which is 14, and ask myself if all my denominators go into it evenly. Does 7 go into 14 evenly? Yes. Does 14 go into 14 evenly? Yes. Does 1 go into 14 evenly? Yes. So 14 is my LCD. So we've got 14 divided by 7 is 2. 14 divided by 14 is 1. And 14 divided by 1 is just 14. Now we multiply. 2 times x is 2x. 1 times y is just y, is equal to 14 times 1 is just 14. Now let's do the bottom equation. 4, 8, and 1. So we're going to do the largest denominator, which is 8. Does 4 go into 8 evenly? Yep. Does 8 go into 8 evenly? Yep. Does 1 go into 8 evenly? Yep. So it's 8. 8 divided by 4 is 2. 8 divided by 8 is 1. And 8 divided by 1 is just 8. So now we multiply. 2 times x is 2x. Minus 1 times y is just y, is equal to 8 times 0 is just 0. Okay? So our y's actually already cancel. So we have 4x is equal to 14. Divide both sides by 4. You get x is equal to 7 over 2. All right, so now we got to take that 7/2 and plug it back in for x. So let's do 2 times 7/2 minus y equals 0. These 2's cancel, so 7 minus y equals 0. Subtract 7 from both sides, you get negative y equals negative 7. Divide both sides by negative 1, you get y equals positive 7. So your answer is 7/2, 7. Alright, let's do this system. So this looks like an elimination one. Is there anything I can multiply x by to cancel negative 3x? Sure is. If I multiply this top equation by 3, that's going to cancel negative 3x because it's going to give me 3x. So I've got 3x plus 18y is equal to 90. And I'll leave my bottom equation alone. Okay, so these cancel. And down here I have 23y is equal to 138. Divide both sides by 23. I know this might be shocking, but I actually don't know this off the top of my head. 138 divided by 23 is 6. So y equals 6. I'm going to plug it back in to one of the equations. I'm going to use x plus 6y equals 30. So x plus 6 times 6 equals 30. X plus 36 equals 30. Subtract 36 from both sides. You get x equals negative 6. So my ordered pair is negative 6, 6. Alright, so here we've got a fraction in the top equation and no fractions in the bottom equation. So we're just going to have to do LCD for our top equation, which is fine. We've got 10, 5, and 5. So we put our largest denominator over here and to see if all of the denominators go into it evenly. 10 goes into 10 evenly, and 5 goes into 10 evenly, so we're good. It is 10. So we do 10, 10, and 10. 10 divided by 10 is 1. 10 divided by 5 is 2. And 10 divided by 5 is 2. So let's multiply. 1 times 3 times x is just 3x. 2 times 3 times y is 6y is equal to 2 times 12 is 24. And then we're going to leave our bottom equation alone. Okay? So what can we do to one of the equations to get something to cancel? Well, our x's are actually the same number. They're just the same sign. So why don't we multiply the bottom equation by negative 1 to make our signs different, which will make our x's cancel. So we're going to leave our top equation alone. And then we're going to change the signs in our bottom equation because we're multiplying through by a negative. So that makes our x's cancel. And then we get 6y minus 2y is 4y. And 24 minus 36 is actually negative 12. Divide both sides by 4. You get y equals negative 3. Plug back in. I'm going to plug into 3x plus 6y equals 24, which is going to give me 3x plus 6 times negative 3 equals 24. So 3x minus 18 equals 24. Add 18 to both sides. 3x equals, what does that give me? 42. Divide both sides by 3. X equals 14. So your ordered pair is 14, negative 3. Okay? All right. Number 13 is a substitution problem waiting to happen. We've got y solved for right here, so we're just going to plug in for y right here. And so I have x minus 5, but instead of y, I'm going to plug in here because we know what y equals. So it's 1/5 x plus 6 is equal to negative 30. So I'm going to distribute this 5 to both pieces. So x minus, now this and this 5 is going to cancel. So it's minus 1x, so just x, minus 30. Negative 5 times 6 is negative 30, equals negative 30. So x minus x is 0, and you end up with negative 30 is equal to negative 30, which is a true statement. So your answer is infinitely many solutions, or all real numbers, or how they write it all crazy in the book, however you want to say it. All right, here's another one that's set up to be solved by substitution because x is already solved for, so we're going to plug it in here for x. So 5 times negative 2y plus y, I don't know why they wrote 1y, that's weird. So you have 5 times 2y is negative 10y plus y is equal to 27. So negative 9y is equal to 27. Divide both sides by negative y, or by negative 9, I'm sorry. Y equals negative 3. So I'm going to plug into x equals negative 2y. X equals negative 2 times negative 3. So x equals 6. So my ordered pair is 6, negative 3. All right. Now this one is also set up to be solved by substitution because I'm just one step away. If I divide everything by 4, I get y equals 3 minus 2x. And then I can plug this in for y right here. So I've got 2x plus 3 minus 2x is equal to 3. So 2x plus 3 minus 2x equals 3. 2x minus 2x cancels, leaving me 3 equals 3, which is a true statement. So your answer is infinitely many solutions. Okay, 16. Looks like a elimination problem to me. I'm going to multiply the top equation by negative 3 to get my y's to cancel. So I have negative 9x minus 3y equals negative 12. I'm going to leave my bottom equation alone. So notice your y's cancel. This leaves me negative 7x is equal to negative 14. Divide both sides by negative 7. You get x equals 2. Plug your x equals 2 back in. You get 3x plus y equals 4. So 3 times 2 plus y equals 4. So 6 plus y equals 4. Subtract 6 from both sides. You get y equals negative 2. So your ordered pair is 2, negative 2. All right. Here's another one that's set up for substitution. Y equals negative 5x, so that's going to go in here. So negative 5x plus negative 5x is equal to negative 10. Negative 5x minus 5x is equal to negative 10. So negative 10x is equal to negative 10. Divide both sides by negative 10. X is equal to 1. Y equals negative 5x. Y equals negative 5 times 1. So y equals negative 5. So your ordered pair is 1, negative 5. All right, we've got x plus 7y equals 7 and 6x plus 8y equals 42. So I'm going to try to get rid of my x's by multiplying the top equation by negative 6. So I've got negative 6x minus 42y is equal to negative 42. Leave my bottom equation alone. So these cancel. Negative 42 plus 8 is negative 34. Y is equal to 0. Divide both sides by negative 34. You get y is equal to 0. Plug that into one of your equations. Doesn't matter which one. I'm going to choose the top one. So x plus 7 times 0 is equal to 7. X plus 0 is equal to 7. So x is equal to 7. So my ordered pair is 7, 0. All right. Here I've got negative x and 9x. So if I multiply the top equation by 9, my x's will go away. So I've got negative 9x plus 45y is equal to negative 81. And 9x minus 45y is equal to 3. So it looks like my x's and my y's cancel, leaving me 0 on the left is equal to negative 78. That's not a true statement, so we can say nope. So your answer for this would be no solution. If you get a false statement, which this here is a false statement for sure, your answer is no solution. All right. So number 20 looks like I'm going to try to do the y's here. If I multiply the bottom equation by negative 3, then my y's would cancel, so I would leave my top equation alone. And my bottom equation is going to become y's will cancel. 2 minus 33 is negative 31. And then negative 49 minus 168 is negative 217. Divide both sides by negative 31, and you get x equals 7. Then you're going to plug in 7 into one of the equations, doesn't matter which one, for x. I'm going to choose the top equation. So you have 14 plus 9y is equal to negative 49. Subtract 14 from both sides. 9y is equal to negative 63. Divide both sides by 9. You get y is equal to negative 7. So your answer is 7, negative 7. All right. Looks like we have now hit a system of equations where we're going to have to multiply both equations by something, because I can't make 3 negative 7 in order to cancel 7, and same thing here. So we're going to multiply this equation by 7, this equation by 3, but I need one of them to be negative in order to get them to cancel. So I've got negative 21x minus 49y is equal to 224. And I've got 21x plus 9y is equal to negative 24. So your x's cancel. And you have negative 40y is equal to 200. Divide both sides by negative 40. And you have y equals negative 5. And you're going to plug back into one of your equations, doesn't matter which one. So I've got 3x plus 7 times negative 5 equals negative 32. 3x minus 35 equals negative 32. Add 35 to both sides, you get 3x is equal to 3. Divide both sides by 3, you get x equals 1. So your ordered pair is 1, negative 5. Okay? All right, we've hit the word problems. So we have one number, so we're going to say x is our one number, and y is our second number. Okay? So one number, x, is our indicator, guys. Is always equals. 1, remember, less than means it goes towards the end. A second number, so y minus 1. And then we have twice the second number, so 2y, because y is our second number, is 4 less than, so we know that's going to go at the end, 3 times the first. So 3x minus 4. And now we're going to solve this. We're going to use substitution because we have x is equal, so we're going to do, and this is our system, 2y is equal to 3, and instead of x, we're going to do y minus 1, because they told us x is y minus 1, minus 4. So distribute your 3. So you have 2y is equal to 3y minus 3 minus 4. 2y is equal to 3y minus 7. Subtract 3y from both sides. You get negative y is equal to negative 7. Divide both sides by -1. Y is equal to 7. And then we're going to go back up. Oops. Go back up to the top here. I got x equals y minus 1. So x equals 7 minus 1. So x equals 6. So your ordered pair is 6, 7. Or your numbers are 6 and 7. So here we're going to do again. X is our one number, and y is our second number. Okay, so one number, x, is 3 less than, remember that goes to the end, a second number, so y minus 3, twice the second number, so 2y is, that's equals, 48 more than, so we know that's going to go to the end, so we're going to have plus 48 on the end, 5 times the first, so 5x. So we're going to sub y minus 3 in for x. So 2y is equal to 5 times y minus 3 plus 48. Distribute your 5. 2y is equal to 5y minus 15 plus 48. 2y is equal to 5y plus 33. Subtract 5y from both sides. You get negative 3y is equal to 33. Divide negative 3 from both sides. Y equals negative 11. And you have x equals y minus 3. So x equals negative 11 minus 3. So x equals negative 14. So your numbers are negative 11 and negative 14. Okay, 2 cars leave a city and head in the same direction. After 6 hours, the faster car is 18 miles ahead of the slower car. The slower car has traveled 282 miles. Okay, so this might look familiar because this was the bell work, but we're going to go through it anyway. Okay. So we have x is the faster car and y is the slower car, right? And you have 6x is equal to 6y plus 18 and 6y is equal to 282 because 6, because of the hours, the 6 hours, 282, because that's how many miles the slower car has traveled, and y is the slower car, and the slower car is 18 miles behind the faster car. So that is our system of equations. Okay, so now we need to solve it. So what I'm going to do is I'm going to divide 6 from both sides here to get y equals 47. And then I'm going to take this 47 and plug it back in here to find x. So I have 6x is equal to 6 times 47 plus 18. So then you have 6x is equal to 282 plus 18. So you have 6x is equal to 300. Divide both sides by 6, you get x is equal to 50. So the faster car is going to 50 miles per hour, and the slower car is going 47 miles per hour. And that's your answer. Okay? So we have University Theater sold 493 tickets for a play. Tickets cost $23 per adult ticket and this should be dollars per senior ticket. If total receipts were $8,270, how many senior citizen tickets were sold? So make sure you know what they're being asked. Okay, so here's our two equations. $23 per adult tickets, so 23A plus $14 for senior tickets, 14S, is equal to $8,270. That's total profits. And then A for adult tickets plus S for senior tickets, 493 tickets sold. So that's our system, okay? So I'm going to subtract S from both sides to get A is equal to 493. Oh, actually, I'm trying to figure out, let me back that up, because I want to know senior tickets, right? What's that? What's being asked? How many senior tickets were sold? So let's actually subtract A from both sides so we can solve for S, because we want to know how many senior tickets are sold. So that's going to give me S equals 493 minus A, and we're going to plug that in right here. So we have 23A plus 14 times 493 minus A is equal to, no, I was right the first time. Back it on up. I was right the first time. I should solve in the beginning for A so that I get S right here. I was right the first time. Okay, let's try that again. So I don't know why I erased all that. That was dumb. So 23A plus 14S is equal to 8270. And then A plus S is equal to 493. So I'm going to subtract S from both sides. Well, it's prettier that way anyway. A is equal to 493 minus S. So now I'm going to plug this in for A. So I have 23 times 493 minus S is equal to 14. Plus 14S is equal to 8270. Okay, now let's solve for S. So I'm going to distribute the 23. So 23 times 493 is 11,339 minus 23S plus 14S is equal to 8270. So I have 11,339 minus 9S is equal to 8270. So I'm going to subtract 11,339 from both sides. That's going to give me negative 9S is equal to, so 8270 minus 11,339 is negative 3069. Divide both sides by negative 9, and you get S equals 341. And that is how many senior citizen tickets were sold, 341. Now you could plug 341 back in and find out how many adult tickets were also sold, but they didn't ask for that. They just wanted to know how many senior tickets were sold. So make sure you're answering what they asked for. A vendor sells hot dogs and bags of potato chips, or turkey burgers and sweet potato fries. A customer buys 2 hot dogs, so we're going to do H is hot dogs and bags of chips. C is bags of chips. Okay? For $8. So 2H plus 5C equals 8. We're talking about money, so leave it like that. Another customer buys 3 hot dogs and 3 chips for $7.50. Find the cost of each item. Okay? So now solve the system. You're going to have to multiply both equation by something in order to be able to solve the system. So I'm going to multiply the top equation by 3 and the bottom equation by negative 2. So that's going to give me 6H plus 15C is equal to 24. And then down here I'm going to get negative 6H minus 6C is equal to negative 15. Okay, so my H's cancel, leaving me 9C is equal to $9. So divide both sides by 9, you get C equals $1. So you know that the chips are $1. Okay, but now we need to figure out how much the hot dogs are. So we're going to plug 1 in for C and figure out into one of the equations. So I have 2H plus 5 times 1 equals 8. 2H plus 5 equals 8. You can leave it at $8 if you want. Subtract 5. 2H equals 3. Divide both sides by 2. You get H equals 3 over 2. Now put that in your calculator. 3 over 2 is 1.5, right? So hot dogs are $1.50. So you've got chips are $1 and hot dogs are $1.50. Okay? Before they break even. So again, C of x is equal to R of x. So you have 14x plus 7,800 is equal to 27x. There's no reason to miss these guys. These are very simple problems. 7,800 is equal to 13x. Divide both sides by 13. So you get x is equal to 600. So your break-even point is 600 units. Okay, how many binoculars must be sold for the company to break even? All you have to do with this is look at the binoculars being produced. The break-even point is your x value, so your answer is just 750. Just look at your x value at your intersection. At the break-even point, both cost and revenue are what? Okay. $2,250. All right. Okay, so that's it. You guys finish the study guide. Have a great night, and I will see you on Monday.